Welcome to the MS Dev Show, episode number 169. This week we talk with Dominik Tornow about how SAP used Azure for an internal application built on top of an event-driven architecture using Service Bus, Azure Functions, Stream Analytics, and much more.
Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com. This episode of the MS Dev Show is brought to you by Expose, the market leader of .NET and Java APIs for file business formats. Natively work with DocX, XSLX, PPT, PDF, MSG, MPP, image formats, and many more.
This week we have Dominik Tornow, Director of Engineering in SAP's Product and Innovation Organization. Welcome.
Thank you very much for having me.
And we have my good friend, Prashant Kabari. How's it going?
Good. How are you, Jason?
Good. So obviously this looks a little different. We're like floating in the abyss or something here. I don't know where we're at. We're nowhere. It's actually in the Channel 9 building. And Carl is obviously absent in this episode, so we've replaced him with Prashant. So welcome, Prashant. So if you have any insults for this episode, you can direct them at Prashant instead of Carl.
I'll pass them to Carl.
Yeah, that sounds good. So we're going to skip all the normal episode formalities. We thought we'd do something a little bit different this episode. And this was actually all Prashant's idea. But what we want to do is deep dive into a scenario with a real Azure customer and what is actually being built on top of Azure. So I thought that was a great idea to really deep dive, and we'll explore that and see what it's like. Because normally we cover a lot of topics around different products and things like that. But this is actual real world software that we just want to dive in and talk about it. So I guess what we should do first is we should talk about SAP first. Like, what is SAP?
Well, the short introduction is SAP is a leading provider of enterprise applications. And SAP is a global company represented all over the world. And I am part of the SAP tools team that provides applications for SAP's internal use cases. So not for SAP's customer, but SAP is our customer.
Okay, very cool, very cool. So you're building some cool stuff there. So I guess the first thing that we should dive into is the thing that we're talking about today, which is MailWave. So what is MailWave?
So MailWave is an application to track the engagement of the readers of SAP's internal newsletters. So basically MailWave tracks the open and the click rates of the recipients to give feedback to the communication teams.
Okay.
And up to date, MailWave had about 95,000 users served and 1.5 million clicks.
Wow. That's pretty cool. That's got to be pretty neat watching, that much data flow through the system. So how big is the actual team that worked on MailWave?
So MailWave is architected, developed, and operated by, I want to say 2.5. That is 2 full-time employees, myself and my colleague. And at any given time, we also have a software intern on board.
Okay. So one of you is a PM and one is a tester? No. No. So I assume both of you are basically devs then, right?
Correct.
Okay.
Yeah. All of us are hands-on, including the interns. Our interns ship code.
Okay. Well, that's very cool. So I guess the next logical question is like, why Azure? Like, why was this even a thought?
Well, SAP uses a Microsoft Exchange infrastructure as a backbone for our email infrastructure, and is also a long-standing customer of Active Directory. And with Azure's Active Directory and the Azure Microsoft Graph integrating into the on-premise systems out of the box, that made Azure a natural choice for a technology provider.
Okay. So you have basically a long-standing relationship with Microsoft. And obviously, whenever you live in that ecosystem, it's favorable to use a lot of the same pieces then, I assume.
That is correct.
Okay,
So
very cool.
you mentioned the team of 2.5, right, approximately. So how long was the total time, and what is the experience getting them onto Azure? Did they know Azure before? What is the ramp-up time and experience?
So no, none of us actually had any hands-on experience with Azure before. So I want to say the ramp-up time was, well, that depends on how you define ramp-up time, but definitely the decision was made after a short exploration of the Azure services within a few days.
Yeah.
The actual development time until we reached version 1 was, I do believe, about 2.5 to 3 months until we released the first version of the application.
That's pretty quick.
And that's end-to-end.
That is end-to-end.
The first version.
That is first version end-to-end. That is the master data, the analytics, inbound and outbound pipelines, correct. Also fully integrated into Azure Active Directory.
What we should dive into now is obviously the architecture. So why don't you start walking us through that? Because I know we talked about it a little bit at lunch, and I think we should, I just found it like super interesting, like how many services you actually integrated in. And what we'll do is we'll, through the power of technology, we're actually going to pull up an architecture diagram here. And now you want to walk us through the architecture?
All right.
Maybe zoom in as you walk through it.
Let me see how I do that. Not like that.
Yeah, while you do that, you can also talk about what services and features you used and what are the specific... oh, there you go.
Perfect. Okay, so we're starting at the top left.
So the application itself is composed of mainly, I want to say, 4 parts. Mm-hmm. We have the inbound pipeline. The producer pipeline is where the authors of a MailWave or of a newsletter send that newsletter to MailWave. We have the consumer pipeline where the recipients open newsletters and click on newsletters. We have the core pipeline that is responsible for managing the master data. We have the analytics pipeline that will give you real-time statistics about the campaign. And we also do have pluggable backends for the delivery of newsletter, like for example external via providers like SendGrid, internal via Microsoft Graph API, or also the EWS API.
Okay. And then at lunch you were talking about a heavy dependence on Azure Functions. So how do Azure Functions play into this?
That is correct. So the entire application is made up of Azure Functions. And what that boils down to is that at any point we do not use any compute resources unless the application is actually computing something. And the Azure Functions provide all functionality of inbound and outbound processing, as well as master data movement. Most of the application react to messages on the Azure Service Bus queue, but also some of them are bound to blob storages or to the table storage and Cosmos DB. Correct.
Okay. So I gotta think that like the main source of events in the system is people clicking on a link in an email, right? Because the purpose is to understand like what's actually getting traction and what people are, you know, like where are they at, the information that they're actually interested in, right?
Correct.
So to me, is that right? That is the primary input into the system is all of those clicks? I mean, whenever you send something out, there must be like tens of thousands or tens of thousands of clicks like pretty quickly, I would assume.
That is correct. So the first and strongest response is definitely the open event. Right, as soon as Outlook displays one of the emails.
So this is open for the end user or the consumer of that mail.
The consumer
campaign,
of the
right?
mail.
Oh, so when they even opening the email.
Just
is an
even
event.
opening
how
the
many
email.
Oh,
is an
okay,
event.
yeah.
Yes.
So you get this flood of initial events.
Immediately.
Yeah. So those signals then that's going into an Azure Function.
That is correct. So Azure Function in that case provides a tracking pixel. And as soon as the tracking pixel is retrieved by the Outlook client, we grab that event, put it on a service bus first in order for further processing. So for example, we take geo information based on the IP addresses and also mix in some information about the newsletter that we have in our backend systems. And once the event is enriched, it is going to be recorded on the Azure Event Hub. And from the Event Hub, it is being processed by Azure Analytics streaming jobs.
So what kind of information are you tracking? Do you know how long the user has been in that email or anything like that? Or?
Unfortunately, that is actually not possible.
Okay.
We cannot track that. And since we also do not use individual tracking codes per user, but individual tracking codes per newsletter only, we need to use some heuristics to actually guess if a user opens an email twice, opens an email
or a different
3
email.
times.
Okay.
That is correct.
All right.
But you could track it on an individual basis, right? Because every time you send an email newsletter, or are you sending it to a whole group at one time? Because if you're sending an individual one, you could customize that little tracking pixel, right?
We actually...
The link in there can be specific to the user, yeah.
Correct. The link in there could be specific to the user, but it was a conscious decision not to, in order to respect people's privacy.
Okay.
But technically, that's absolutely feasible.
Yeah, because you're really just trying to get broad analytics, like what are people interested in?
That is correct.
Was this whole email just a waste of time?
That is correct.
Which the data must be a little depressing in some cases.
Well, also correct. But whether you have 8,000 open events or 8,100 on an email that targets 90,000 people does not really matter as long as you know you are in the ballpark.
Yeah. I'm not gonna say did Prashant read that email that I sent out? I sent it to the whole company just so he would get it.
Well, it'll be good to know that if the same person opening the email multiple times or is like a unique event that's occurring.
We use actually some heuristics and also some meta information that we can
figure out.
Exactly, that
without
we can
getting the privacy
grab.
information.
Correct, and we can safely grab without violating the user's privacy.
Okay.
To have a good idea if Prashant clicked twice or if
Somebody
Jason
else.
clicked once and Prashant clicked once.
It's almost like a cookie at that point, right?
Right.
Similar,
Yeah.
correct.
Aspose offers a powerful set of file management APIs with which developers can create applications, which can create, open, edit, and save the majority of popular business file formats. Their product range supports a multitude of file formats, including Word documents, Excel spreadsheets, PowerPoint presentations, PDF documents, OneNote, Outlook, Project, Visio files, popular image formats, and many others. Aspose produces APIs for .NET, Java, and the cloud, which can be utilized in almost any modern language available today. Visit aspose.com for a free 30-day no limitations trial, and if you get stuck, message the friendly support team for help. All technical support is offered free of charge. And remember, if you are a lucky winner, you will receive a free developer small business license for Aspose.net, a powerful toolkit for working with Word documents in your applications.
And you're talking about there were how many users at one time for a specific event, 90-some thousand, or what is the maximum?
Yes, that is correct. We have everything from very small newsletters that are being handled to very large ones up to 95,000 users.
Was that the expectation to begin with? Did you actually had to design for that, or was that kind of just happened?
That is actually a fair question, and I want to say that, of course, we do plan for it because we do know about the size of SAP as a whole. So any SAP employee is a potential user. But on the other side, once you commit to an architecture that is based on Azure Functions, that scale is not that much of an issue as compute resources are allocated dynamically anyways.
Any specific challenges in that?
Yes.
Okay.
Many challenges.
All right, let's
Many
talk
challenges.
Good to know.
Specific to Azure Functions, or are we talking general?
In general, the scaling, and if anything specific that you came across.
Well, maybe we should just start with Azure Functions, though.
Sure.
Did you run into challenges with Azure Functions themselves?
With Azure Functions themselves, no. We did not run into any challenges with the technology. The technology was reliable, and it is also very convenient.
I just love Azure Functions, by the way.
Same here.
Prashant knows, too. I was coming to Blob.
I love it too, but it's just coming from inside versus somebody else talking
Yeah, our
about it.
opinion doesn't matter.
I love the bindings.
Yeah.
All right. The Azure Function bindings, this is my favorite because it makes it just so convenient. And this is also, actually, this is what got me started with Azure Functions. As soon as I saw the bindings, declarative bindings to N data stores, I was like, all right. no more boilerplate of loading table rows and blobs files.
Yeah.
Great. So, but definitely an architecture like that presents many challenges, because we are talking about microservices to the maximum, or as you said at lunch, to the minimum, depending on how you look at it. Absolutely true. And if you think about like where we are coming from, right, from way back, where we are talking about serial execution, right? So we have one statement being executed after the other. Then we added concurrency. With adding concurrency to our applications, we added non-determinism, right? We do not know, does this line run before that line or the other way around, depends on the execution. And then after concurrency, we added distribution. And with distribution, we add the potential of partial failure. This component is up, but this component went down, right? And with Azure Functions being created on the spot as requests come in, right? This is as distributed as it actually gets, and the components are completely, even individual executions of the functions are completely isolated, right? They do not share any state, they do not share a common understanding of the system. So yes, that actually presents a lot of challenges.
Yeah, this is great, because Prashant and I, we talk about that in theoretical terms all the time, right? We're just like, yeah, functions is this magical solution to this problem. So it's great to hear about a real world example where it's like, hey, we just throw our code out there and it just works. I mean, it really is like, you know,
and I think specifically a point about bindings, because if you write your own bindings, it's not just the code, but also the testing you have to do with that. And here, the only testing you have to worry about, or even writing the code, is just the business part, which is what I like. But again, I would like to see your opinion, or was that one of the features that you're looking for, or what is the attractive things about functions as opposed to anything else?
You know, so my background, the area where I do like to venture in is actually also functional programming, and I'm a huge fan of F# as a language. And as most functional developers will tell you, they appreciate being able to control side effects and to reason about their code, right? So side effect-free code or referentially transparent code is actually a desirable goal for the functional programming. Now, if you look at Azure Functions with the bindings of Azure Functions, you actually have a almost referentially transparent execution, right? Same input arguments in, same output arguments out. Same return value out. Right? Because the actual binding, reading from the persistence and then writing from the persistence is done by the environment, by the Azure Function themselves. Okay. This actually does lend Azure Functions to be very testable, because the arguments of the function are available on call, right? And the return value will be processed once it is returned. And the function itself, referential transparent, almost no side effects. So that one I do like in Azure Functions a lot. Okay. Other things is that Azure Functions do integrate into most of the services that Azure offers. We talked about blob storages, right? We talked about event hubs, also the service queues. And the service queues are actually a powerful technology if you want to create resilient and also elastic applications.
Yeah, so just to be clear, there's a couple different types of queues. So it's a service bus queue.
That's a service bus
queue. Okay, I just
queue.
want to make sure we're talking about the same.
It's not the storage queue, it's a service bus queue.
Right. And I want to make sure too, we weren't talking about event hubs yet.
Correct.
Okay.
Yes. So the service bus queues are basically the underlying plumbing for most of our applications, right? So, for most of our functions. So the functions are connected fully in an asynchronous manner, right, via the Azure Service Bus. Okay. Also, the Service Bus does give you some additional benefits. For example, a automatic retry, right? Also, you don't have to take care about that. Correct. It doesn't.
Yeah, it seems like when the event comes into the Azure function, there is a little bit of risk there. If that function were to crash, you're going to lose that event. I'm guessing that's pretty rare, so we can probably assume that risk for a click. Once it's handed off to Service Bus, then like it's safe, right? Then it's like, okay, I'm good to go. Now I can sort of keep its safety throughout the rest of the system.
And I think it's a built-in feature, right? If the function doesn't succeed, it stays in the queue till you actually process it from the queue.
No.
Well,
you guys need to know better than I do. But
Good to learn something today.
But I do believe that it is actually a feature inherent to Service Bus. As long as the message, the delivery of the message is not acknowledged, the Service Bus will, after a certain timeout period, or if an exception is thrown, will redeliver the message.
Exactly.
And Azure Functions are seamlessly integrated into that mechanism, so also you do not have to worry about it.
Okay, very cool, very cool. So let's go to the next step then. So it goes in the Service Bus queue, and then I believe next it goes into Stream Analytics. Is that correct?
That depends on what part of the system we're talking about. But yes, for the inbound,
inbound clicks.
Consumer pipeline. For the inbound clicks, correct.
Okay.
That is correct. So the message goes through a few Azure Functions plumbed together via the Service Bus queues, and then goes into the Event Hub. That is correct.
Okay.
So it goes to Event Hub and then Stream Analytics?
Exactly. From Event Hub, it is consumed by Streaming Analytics.
Okay.
In Streaming Analytics, we apply the aggregates, which basically also means you have to specify a time window, right? So we do timed analysis of, depending on the individual query, sometimes on time windows of 30 seconds, sometimes on time windows of 10 minutes.
So what kind of aggregates are you trying to get in the time window?
Anything from basic statistics, like how many opens or how many clicks on an individual newsletter, how many opens, how many clicks on an individual link, but also aggregates on how many opens were in a certain region in the world.
So instead of storing everything to like this table, like every single click, you're basically aggregating some of that to make that easier?
That is correct. We're aggregating.
That's a good idea.
We're aggregating on the fly with the time window now. And if you think about it, eventually, so a lot of these real-time scenarios, whether it's now web stream click analysis or whether it's IoT devices, they have a very conflicting nature in themselves, right? On the one side, you have a constant stream of data coming in, and on the other side, you usually want to run some analytics on that. You rarely look at an individual sensor or at an individual click. You want to run analytics. Now you have very heavy write load and you have heavy read load, and no database actually likes that very much. So with technologies like the streaming analytics, you have a window that actually acts as a buffer, right? So in real time, you can work on high input data streams, buffer it, aggregate just this buffer, and then move the result of the partial result of the analytics in one go into a secondary data store, like for example SQL Server. That is what, or SQL database. That is what we used for MailWave. So once the time window completes, we write the result of the analysis onto message bus. From there, once again, good old Azure function bound to it, takes the result, writes one SQL Server batch insert, and insert into SQL Server. This way, we actually have an upper bound of how much load, how much write load we have on our database, and are basically handled.
So your process looks like you have some functions with the queue, followed by event functions, event hub, stream analytics, some more queues, and then the data store.
One more function, data store.
Okay.
Correct.
And so what are the functions you have at the beginning, right? You didn't ingest directly into event hub, the events coming in. Correct. So the events that were generated, they don't go straight into Event Hub. You have some function processing before that.
We have some function processing before that. That is correct, because streaming analytics do not allow for arbitrary side effects. Okay. So I cannot use a streaming analytics job to, for example, run an HTTP query, call some REST API, right, to get additional data to augment the raw event. So since we ask for geo information about that IP address,
I guess you could use the UDFs now. Maybe that
the UDFs are powerful, which we actually also do use in order to generate a fingerprint for
we should explain
messages.
what that is.
Yeah, so the user-defined functions, it's maybe a relatively new feature in Stream Analytics where you can read your own JavaScript functions and pretty much do what you can do in JavaScript and enhance the information coming in if necessary.
But once again, you guys need to know better than I do. But I do.
Good learning session today.
Hey, your solution works, so we can't really argue with that. We can sit here and get as theoretical as we want, but at the end of the day, like, your solution works, and that's the proof.
And I do believe that UDF you cannot call HTTP. I did try.
Oh, really?
Yes. Okay. But we do use it for fingerprinting. That is basically to see if one event is most likely to belong to the same person or two different persons.
Okay, that's very cool. So was that the end of the? So that sounds like that's the end of that click pipeline, right? Because now we have the data stored,
correct,
and then we can report on it.
Correct.
So which one should we talk about next? Because what is the next most interesting one from your standpoint? Because I think the click stream is the most important. What do you think?
Definitely for the end user is the most important, because this is where we actually add end user value.
Right.
One that I actually like very much is handling of our master data, because also that happens in Azure Functions.
Okay.
And it follows an event-sourced model and a CQRS, command query responsibility segregation model flow. And we use the Cosmos DB as a data store for our event stream. So we have, maybe we can show the architecture diagram.
Sure. I have the power.
Oh no. Hold on.
Hold on.
You do have the power, but
I thought I had the power. Wait, wait, I'm charging up. There we go. I'm back.
Okay. No, we got the power back.
Okay, here we go.
So aggregates, like for example a newsletter, right, are also implemented as Azure Functions, and we store individual events instead of a final state. So, you know, in classical applications, you move the state n to state n+1 and then save state n+1 in the data store, replacing state n. So we decided for our application not to only save the state of each operation, but actually save the event that led to this state. And we recreate the event, we recreate the state of any aggregate, which is basically any object like a...
So what is kicking off this whole process? What is the actual event that happens?
So the actual event that happens is, for example, so here a command comes in. The command, let's call it create newsletter. So the command create newsletter comes in, is then validated, and in case the validation checks out, an event is raised, newsletter created.
Okay.
Then this event is saved to the event stream and persisted in Azure Event Store. In Azure Cosmos DB. And also put on a message queue for further processing, which we have event handlers. In the aggregate, these event handlers update the read model. So, for example, after you process the command newsletter created, and it gets transformed in the event. Create newsletter gets transformed in the event newsletter created. Then the read model updaters will make sure that there is a row in the database reflecting that newsletter.
Okay.
Now the next command comes in that may be something like deliver newsletter. That command again is validated. the event newsletter delivered is being raised. The state of the aggregate is recreated by reapplying the entire history of the event. And then the event handlers are going to update the read model again, moving the newsletter from the created state into the delivered state, and then also the delivery pipeline is kicked off.
Okay. So earlier you mentioned you use SQL database, and in this case you're using Cosmos DB.
Correct.
So why are there two different database technologies?
Well, for Cosmos DB, so each event has a different payload, right? Depending on what you're about to do, whether you are creating a newsletter, whether you're delivering it, maybe you have to deal with timeouts, updates. All of these events carry different information. Right now, Cosmos DB, one of the storage engines being a document DB, is very flexible on the contents of the newsletter. On the contents of the event stream, right? So we are basically using Cosmos DB here as a document store, and we store a array from previous events, and the arrays and the events in the array, they do not share a common schema. They're just JSON events.
Well, that makes a lot of sense then. So I'm curious then, if you so which interface are you using? Are you using the document DB interface to Cosmos, or are you using the MongoDB interface?
Document DB.
Okay.
Yes, we
and
are
that's
using
just,
the
I was just curious.
SDK.
Yeah.
Okay, so yeah, and it's interesting because you have the whole history of the events that have come in.
That is correct.
And what are you using it for? I mean, to have that whole history chain, what do you do with that entire chain?
So the history, of course, gives you on the one side auditability.
Okay.
That is a hard word for a German. Auditability. Just tell me I said that correctly.
You said it correctly.
Wonderful, thank you. And on the other side also enables you to deal with situations like, for example, conflicting messages, timeouts, because from the event stream you can recreate the current state of the system. And remember, with the microservices, we did add concurrency and we did add distribution. Now, in a linear execution, right, the actual state of any program, sometimes object, is represented by the program counter, right? I'm on this line, I'm on this line, I'm on this line. Now, in concurrent situations, in distributed situations, that goes away. So you have to actually handle your state machine yourself. This is what we are doing, and the events.
So the sequence is coming randomly, and you need to put that together.
That is correct.
And it's auditability. Somebody made a request, and you need to know why it didn't happen or where it broke. That's the whole idea of auditability.
That is also correct.
Okay.
And we actually do have plans to implement fallback mechanisms. Let's talk about failure a little bit, because it's one of my favorite topics, because it's very hard to actually tackle. So in distributed systems, right, you have the callee, you have the caller, and it is very hard to determine, from the caller's point of view, did a message not get delivered? Did the callee crash randomly, or did a response not arrive with the caller? Right. So in this situation, you actually do not know, has any command taken effect? Right?
Okay.
Has my email be delivered, for example? And in these situations, what's usually done is you add a timeout. Right?
Okay.
Now, Azure Functions, they react to events, right? You have the Azure Function trigger. Every binding has one trigger. They react to events. However, basically by definition, the functions do not act to the absence of events, right? So in that case, what we did is we used a feature of the service bus and scheduled a message for the future.
Okay.
So just before we actually schedule the message to process a work item, like for example, send an email, before that we already sent us the notification to check for a timeout.
So expecting something to happen in the future,
Double check on that.
And we talked about that at lunch too. I didn't even realize that you could send a future message in Service Bus.
And
that was totally new to me.
It's actually just one key setting.
Yeah.
That was in a snap. So from there on, we do expect a delivery confirmation. Our service is built in a way so that it eventually confirms that you got the message or you delivered the email. However, eventually that message that we scheduled for the future, right, will fire. And then we come back to our full event stream, right, and check, well, did we get in any of these events, did we get the confirmation for the message?
Okay.
If we did, we're all good.
All right.
If we did not, then we need to raise an event that signals
Some failure, yes.
some failure, a timeout occurred. We don't know what happened. Also an interesting point, we don't know what happened, right? Did the email go out or did the email not go out? We actually have no way of knowing, right? And the service level agreements of the service bus say that once the message is accepted by the service queue, the message will be delivered.
Right.
Maybe delivered more than once.
At least once delivery.
At least once delivery. Correct. So this is the first one that may actually come around and haunt us, right? Then we have timeouts. They may come around and haunt us because once a timeout occurred, well, did the service fail before or after sending an email? Tricky, right? So in certain situations where you have idempotent operations, doesn't really matter, just do the whole thing again, right? Insert in a database, usually tricky. Update in a database, also tricky. Upsert, idempotent. Just try again and again and again, right? Sending an email, not that much. And especially if you have 90,000
Yeah, you don't want that.
Yeah, people don't like getting a lot of emails that are the same thing.
And I don't like getting a lot
They'll all
of angry
start-
phone calls.
Yeah,
Put it in
they'll
the
all
spam
start-
folder after that. Yeah.
Well, no, they're all gonna start replying like, "Why did you send this twice?" And they're just gonna make the problem worse, or it'll be a reply all
Reply
nightmare.
all, yes.
We know a little bit about that at Microsoft.
And I'm going to get the calls, you guys know it.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications, supports all major programming languages and platforms, and integrates with your current development workflow tools too. There's a free 14-day trial, and it takes minutes to implement, so start resolving issues in your application and check it out today at raygun.com.
So interesting. So you have the option of showing the creator of the newsletter the entire history, possibly almost like the Domino's pizza, right? You order the pizza and say it's in the oven. Wow, the newsletter has been created, it's being sent, or things
Your
like
newsletter's in the oven.
that. It's almost like being in the
No,
oven.
you're
it's being
right.
cooked.
That's right. It's cooking. It's being delivered. No, that's a good analogy.
And it's actually correct, and it is part of our user experience and of our UI.
Wow, that's nice.
Now, one of the features of Azure we use to, for example, guard ourselves from sending multiple emails is the Blob Storage check and set operation. So before we send an email, we guard the operation with a check and set, which basically means we create a blob in the blob storage only if the e-tag has not been set. That is a guaranteed atomic operation. And the Azure Blob Storage will then make sure that only one of the concurrent components in the system will ever attempt to send the email. Now with that, we scale it down from from at least once to at most once. Unfortunately, with arbitrary side effects, you can never guarantee exactly once. But in our case, we figured we rather drop it than sending it multiple times.
It's a very interesting strategy because I've seen that used many times. In fact, the Event Hubs client uses Blob Storage, and it gets leases on the Blob Storage to figure out how many concurrent readers it can use. So it's just funny how Blob Storage is so foundational and has these properties baked into it, and then you can just piggyback on that. So I think that's just a novel use of Blob Storage.
And it was actually a very convenient implementation. A few lines of C# code that solves a very fundamental problem in distributed applications. Right? You need to reach consensus about a state. Right? Has it been or has the delivery been attempted yet? And with a simple call, create blob if etext does not exist. Right? That is guaranteed for the application. Checkmark done.
Yeah, push that problem onto somebody else. I love it.
Correct. That is the beauty of being an application developer.
Yeah.
Right? Infrastructure developer have nowhere to push it.
Well, it's interesting. Like the thing we talked about in the beginning was kind of the evolution of how you build applications like this. And I mean, I'm just thinking 10 years ago, like how would we have built this? And obviously, it wouldn't be like tremendously difficult. Like I think it's a nice problem that we can all wrap our heads around. But 10 years ago, we would have built this completely different. I mean, it would have been like a C# application, and I probably would have done pretty much everything in the database as far as like tracking emails and things like that. I'd run into really weird scaling issues because you're going to get tons of traffic right whenever you send an email. And then you're going to have to scale back down somehow. So I'd have to like really over provision. I'd have to buy probably some beefy server to do this. I can't even think of all the problems that I would run into. In your case, you're just like, oh, we threw Azure Functions at it. It handled that for us. We needed to figure out concurrency, so we used Blob Storage, and that solved that for us. We used Cosmos DB. Like I think it's just it really is like a match made in heaven for this, at least for this particular example. Of how it just really simplifies your life as a developer.
Yes, for this application, absolutely. We also came to a similar conclusion that without the cloud and the cloud development, that you would not be able to deliver an application like this, either with the qualities and non-functional capabilities it has, or in the amount of time, right? So because we still talk about 2.5 developers, right? 2 full-time, 1 intern.
Yeah. Well, I mean, about a decade ago, I started a job at a different company, and I had to write an application. And I said, okay, where am I hosting this? And they said, let me know what you want me to order. And I'm dead serious. So like I had to like pick out like it was an HP server that I had picked out, and then I had to wait a few weeks. I had to wait like 6 weeks for this thing to show up. I had installed the operating system on it, and then I installed I think I did some virtualization on it, and actually had to go through that whole thing. I mean, like that process took me as long as it took for you to do the whole application. Obviously, concurrently, I was able to write the application.
It's interesting because recently I was talking to a partner, their data center, and they said make a requisition for a VM. And it takes them about 5 days to get a VM, and I'm saying, what does that even mean? So, to have this concept of, I just have a function and it just works. Well, it's magical to these people.
And what happens when the requisition is denied? I mean, I've had that happen.
It might take 3 days to know that it's denied.
I was at a different giant megacorp that shall remain unnamed, but I needed $100 to finish like this critical project, and it was denied. And I'm like, are you kidding me? It was the craziest thing. So it's nice being able to take this in your own hands like this.
Let me tell you a little anecdote about how the application is actually able to scale.
Sure.
So we scaled the application way beyond the intended limit. Thanks to Azure Service Bus and Azure Service Bus queues and dead letter queues. So we have the Azure Service Bus queue, correct? And after the Azure function retries, or after the environment retries to call the Azure function, I believe default 5 times, right? It will move the message to the dead letter queue. So then on the dead letter queue, you can actually again register an Azure function. So we had an Azure function registered on the dead letter queue to push a notification that we have a dead letter to Microsoft Teams, right? So that we would see it in Teams.
This sounds bad.
So what we did not realize is that once a dead letter queue function, once a dead letter queue message cannot be successfully delivered, it is again being pushed on the dead letter queue, on the same one. So we did have a bug in the Azure function that handles the dead letter queue. However, we did not notice a bug. And we also did not expect any messages to show up in Microsoft Teams because a dead letter message was supposed to be a rare event, which it was. It was a very rare event. However, eventually it happened.
So you found out the scale of Teams?
we found out the scale of Azure Functions because we had one message, or actually
One
we
event,
had like a handful. We had a handful of messages in the dead letter queue
That just kept on
that just
repeating.
kept on
So you
repeating
actually
themselves.
discovered an amplification attack for doing DDoS attacks.
Well, the application itself was not DDoSed. My wallet was. But the application itself was not DDoSed.
Yeah.
We did actually do a postmortem. We had, I do believe, over 500 million invocations of the Azure function. Yes.
And that's just because of the dead letter queue?
Yes.
Oh.
Which is like $3, by the way.
That is true. It's true. Investigation showed that about 400 virtual machines were deployed just for this function in order to keep executing. Right?
Okay, so it scales well.
It scales very well. We did not notice because the application itself wasn't affected whatsoever, right? So we only noticed the next morning when Application Insights notified us about a sudden spike in executions.
Yeah.
Well, that's good though.
Was good,
Yeah.
But which was it was a surprise, yeah. But absolutely, the application or the Azure function scaled well, and the application was not affected. And we did learn a valuable lesson that is just set an upper bound limit.
So Dominik, we talked about stream analytics, but I think you're also doing a lot of other analytics on the data coming in. Or is that already there, or is that being planned?
We do some. So most of the analytics happen online and in real time to provide the feedback right away. We do have some data processing. For example, when an email comes in, we have a few, or a newsletter comes in, right? We have a few Azure functions that process these newsletters. The newsletters are stored in the Azure Blob Storage. And for an email that comes in an EML format, we generate an HTML file in order to show it as a preview on our web interface. And these are Python functions. These Azure functions are implemented
you
in
were
Python
talking about that as well, yeah.
because batteries included. Whenever you want to parse an email, you use Python.
Okay, it's good to know.
That yes, we did also learn.
Actually,
that.
I think even almost the more important point here that I didn't really even think about before was, there's this magical world that I always think of where I'm writing my code. I'm in Visual Studio and I'm writing like some C# code, and then I'm like, I need to process this other thing. So I wish I could switch into Node.js, and then I wish I could switch into Python. But Azure Functions basically opens up that world to you because you can have a function written in one thing. I need to parse an email message. So now I'll spawn out to Python, and it can do its thing and then send it back over or do whatever.
And the bindings are pretty much the same no matter what language you use.
Bindings is the same.
Yeah, because you mentioned most of the functions are in Node.js, correct?
Actually, most of the functions in the core of the application are in F#.
Oh, okay.
And some peripheral functions, especially around the clickstream analysis, some peripheral are in Node.js.
Okay.
That is correct.
So then some are in
you have
Python.
F#, you have C#, you have Node.js, and Python.
That is correct.
Okay, amazing.
That's awesome.
And
Normally
they
that
are-
seems like it'd be like a nightmare, but I mean, it's got to be fun, like posting a job, asking for all 5 of those, but...
And it's being used with the same team of 2.5. They're all mix and matching.
Yes,
without
correct.
any conflict of frameworks or tools and.
No. So we had especially with the possibility to actually choose for individual parts of your application, choose your technology stack without regret. I mean, nobody complained about that.
That's so cool.
And the tools, in terms of tools, are you just using the portal or using through Visual Studio? What's the preferred way for your team?
Also, in general, I want to say that in our team, we do not demand a certain tool set, nor do we demand a certain workflow. However, most of the team gravitates around. Well, most of.
I was going to say there's 2.5. So 1.5 gravitate toward one.
Well, basically 2 gravitate around Visual Studio Code, and then we usually convince the intern. Just give it a try. But if the intern wants to use Vim, they can totally use Vim.
Okay.
And so we use that as our IDE, and we have a simple GitHub workflow. So the Azure Functions are hooked up via the deployment settings to the GitHub repositories. Right. However, we also, especially for exploration, and for experimenting, we also use the in-browser Visual Studio Code that's available under the app services.
Okay, very cool. Now, we talked a ton about like the good and all the great technologies you used, but I wanted to see if we could talk about the bad. I don't know if there is bad, so I'm kind of just fishing, but is there anything that's top of mind that like just didn't work well, or did you go down any technology paths where you started using something you're like, okay, this is not good for this problem?
Well, of course, since as we talked about in the very beginning, right, we did not have any previous experience with Azure. So I want to say that we did take a detour or a wrong path here and there, because we needed to see about the capabilities and the properties of the individual services. So, for example, you can choose from Azure storage queues, you can choose from the Azure Service Bus, and then you also have the Event Hub, right? And while at first glance all of that may look very similar, right, you have to actually find out what the details are. Right? And then once you know that, then it is fairly straightforward again to actually apply it to the problem at hand, because then you can think through the problem and know this lends itself to the storage queue, this lends itself to Service Bus, or this is definitely Event Hub appropriate. But of course, that comes with a learning curve, right? And other than that, most of the challenges that we faced are inherent to the fact that we chose the path to go down a distributed application.
Okay. So I know that you're actually using this internally. Do you consider it done? Are you moving on to something else? Or are you continuing to add features to it?
Well, that always depends who you're asking. You ask our end users, they say more.
Yeah.
You ask our boss, he says less.
Yeah.
So, but we are definitely moving forward with MailWave. So one of the current changes we implemented was to have actually more information about the geo information of our recipients. So with the Graph API, we hook into the address book. We resolve mailing lists of the individual mailing lists. We count the recipients and what regions they are in. And we collect and store this data now as a preparation to use some machine learning to actually predict, for example, the best sending times for an email to get the highest engagement at SAP. And for that, we have we will introduce a connection to Azure ML soon. At least that's the plan.
So that's in the works right now?
That is in the works, correct.
Another feature that I've heard people propose this like internally, and not on like the Outlook or Exchange team. So don't take this as like official, like roadmap. But I've heard people like within the building that I work in mention like, hey, Outlook, whenever you send to a big distribution list, it should tell you like the cost of the time. Like it's estimated to take 5 minutes of everybody's time, and then take all their salaries and figure out what 5 minutes of salary is. So that's a feature idea for you. So whenever you send it to the entire company, you can say this will be, I don't know, $50,000 worth of time that you're about to take.
Yeah, something we ignore, like what time people are spending on this stuff, right?
Yeah.
The other interesting thing, Dominic, you mentioned, I think around lunchtime that, it's being used for SAP's work-related stuff, but there are also some other interesting cases. Can you talk about that?
Well, yes, we do have some usage where we are as a team just happy because it is just a cute way to use the application. So one of our colleagues actually uses it to manage his theater group, who is partly SAP employees, partly his friends. And one of our colleagues in India actually used MailWave to manage parts of the invites for the invitation for his wedding.
Okay.
There you go.
So it can be a party software, right?
Very cool.
Most of it is, of course, serious business.
Sure.
Anything else you wanted to mention, or any other questions, Prashant?
No, I think that looks pretty good. We talked about the future plans. So what are the big learnings from this, and are you using it in some other applications you're working on?
Yes, if we get the chance, we will definitely consider using Azure in the future. Our working with Azure has been very pleasant. So, but of course, it always depends on the application and the use case at hand, whether the intersection of use case and technology lands square on Azure. But for MailWave, it definitely did.
Okay.
Very cool. Yeah. So where can people find you? Are you on Twitter?
I am not on Twitter.
Not on Twitter.
I am not on Facebook.
You're off the grid.
I am on LinkedIn, but
Okay.
that picture, I have more here.
Okay, so they can find you on LinkedIn. What about you, Prashant? Can people find you online?
LinkedIn would be good.
Okay, you can find Prashant on LinkedIn. And you can find me on Twitter at twitter.com/ytechie. And Dominik, thank you so much for coming on and talking about MailWave. And thank you, Prashant, for stepping in for Carl.
Thanks for having us here.
Yeah.
Thank you very much for having
Thanks
us.
for making the trip. Appreciate that, Dominik.
It was my pleasure. Thanks for having me, guys.
That must be one of our listeners. They're super excited to.
Are there questions? Are there any questions online?
Hello, caller. I'm not editing that out, by the way.
Oh, no, come on.